Okay, this is where we ended last time when we were modeling. We were now viewing the action effects based on the soil due on the foundation from applied loads. So right now what we are going to do is now to the next thing that we were supposed to do was now to get two things that are critical. That is the traffic load, and then after traffic load, I want to also get to come up with the traffic load. Temperature, we may leave it for now because but in future we shall apply. We shall continue interacting to share knowledge. We shall do it. That for now I'm going to leave certain things out. I'm going to concentrate on the traffic. Then there's what they call how do we prepare to do the design. We create what they call domain, and then you define the foundation, you define the bottom slab, the approach slab, everything. You'll see the process. So right now what we'll do, you go back to the modeling command, and then since we are going to do traffic, there are three steps you do. Let's first activate the top slab. And now the traffic is moving from the bottom up. That's the traffic, and this seems to be the center. So what we are going to do, this is a surface. This is our surface. Or what has happened is power has gone, but it will not disturb. It will not affect us doing what we are doing. So let me record this. So what will happen is how we have already explained the lane. So what you do, you go to loads, you come to moving loads, and then here under moving load code, you come and there codes the Acheto, LB, Canada, BS, Australia, Poland, South Africa, Korea. But I think in this case I'm going to do Eurocode. So because it was already run, it's telling me analysis design result will be deleted. Say yes. So now I'm now ready. If I go back to, you see now it has given me the traffic line lanes. It has given me the traffic surface lane. This being a plate, this is the area you do. You are creating your lane on the surface. If there were beams, and we are going to learn in others, there are beams, and you create what they call the surface for the traffic to move, then you use the traffic lines. But in this case, we are going to use the traffic traffic surface lane. So now this being, of course, there could be an error in allocating the center, but I assume this is my center, and therefore I'm going to go and say do for me the traffic lane definition, and I come here and I say you add for me the lane. So this lane, I'm now asking the lane, then I type my lane 1. Then this lane, we have both the positive on the right hand side and the negative on the left hand side, or either way, but at least you know if the center line is in the middle, then you are doing, if you choose to go at the axis of Y at the edge here, then it will be one way. You start from you make sure you use this line as a datum or a basis to define the different center lines. Please don't forget that. But for us here, we are doing it from the center, where we shall have remaining area on either left and right. So I come here. Our lane width is 3, standard for the Eurocode, and then we have the wheel spacing for Eurocode. You know it is 2. Then the offset distance, now we are at the center, you saw it. That means I'm 3 meters to the right and 2.2 meters. Then also to the left 3 meters and 2.25. So I'm going to come here and indicate. I told you that the offset to the center line, it is 1.5 because I'm at the boundary of the two lanes. You have the 3.5 to the 3.5 to the left and 2 meters. Then the 3.5 to the right and 2 meters. So that gives you 5.5 and 5.5. So if you do the national lane as per Eurocode norms, then it is 3. The next would be 3. But because I have the remaining of 2.5, that become 1 lane and a remaining of 2.5. So now I have my offset at 1.5, And then my start 00 will be here. I have no problem. Then I come and click on to make sure it is active, picking 2 points. So I pick this. If this is my center line, I am picking this, and then I go and pick the last lane. Then it has highlighted, so I apply. You see that now it is to the right, and it gave the 1.5, but now that was the center line, but the width is 3, so it has given out the 3-meter width. Then I cancel that. Lane 1 has been added. I'm going to add the remaining lane. So remaining area 1 to the right. It was 2.5. Now center line of half of 2.5 is 1.25. So the wheel spacing is, because it's 2.5, the wheel spacing will remain 2, and then the offset distance to the lane center is 1.25. You add to 3, you get a 4.25. And then I come and indicate where I'm highlighting. Please don't change the center. The center remain. This point, you don't change it. It has to be the same you are using it for applying. There you go. So now you applied both the lane and the remaining lane on the right hand side as positive. That means the left hand side will be the negative value. The same thing but negative, and with the same data. So if it is a cancel, now I'm going to add my lane 2. Lane 2, which is a 3, width is 3, the wheel spacing. Now this time the offset is negative 1.5, and then I make sure I put the 2 point here. Then I come and do my lines here, and then apply. Now we are moving to the left. Then again I have added. Now I'm adding the remaining lane but 2, but on the left hand side with a negative. So this has become negative 4.25. You have now known how to add that. So I put this one. I come here. I do that. I apply. So I'm done. I've applied all the lanes, all the remaining lanes. If I needed the walkways, the rest I would do the same. So that is done under the lane. So when you're done the lane loading, the next is you go to the vehicle. You have now created the surface, you have created the lane. What are the vehicles to use the lane? You add your standard vehicle. Now under Eurocode, we have the load models. And now, by gentlemen, this table, if you read more Eurocode, you're going to learn how to adjustment factors are here. So for now, I'm going to do as though it is cram work, but we have been using it. So on lane number 1 with the 300 tandem system, it is normally 0.61, and then the under 200 and the 100 tandem system, it is 2.2, and then 2.2, and then your remaining lane, it is also 2.2. Now in all this, if you multiply with this one, you're going to get a 5.5 as a UDL. That defines normally what happens when you're dealing with lane. So you're going to have your tandem system. Those axle loads remain standard the way they are. However, the distribution factors of 9 will be brought into, so 2.2 by 2.5 and then 0.65 by 9, they all come to around 5.5. So I apply this. It has gone there. So what is the next one? Load model 2, I need to apply. Load model 2 is given here, I apply. It has gone there. I need to go to load model 3, but on a UK and annexes. And then what is normally what these are the standard vehicle. With time you're going to learn. Normally for British standard we have HB unit 30 unit HB 37.5 and 45, being that's about 180 ton. Now under this one we have the standard vehicle of 80. This is 80 ton. You have 100. You have 1. So normally you adopt like 196, or it depends on the kind of loading. So for here, let me adopt SV 100 and I apply. Now having done that, I think these are the loading I could do for. If I was doing like other traffic, like the steel composite and rest, I would do if there was a footway or walkway, I would come and do footway and footbridge. The footway would give me definition so that you apply, and it's activated when people are using the bridge, the pedestrian. Then fatigue can also be done. If this box culvert is being shared with the railway, the train. Therefore, I can also activate all that. So for this case, we can leave it at this, and then we say we have added. So you look at the tree menu here. So the tree menu now has, this tree menu is on either side. So this way you can see how you are modeling. So now we have added traffic lane with the remaining, and then other lanes. Then you have the vehicle. We have added 3 types of vehicles. That is going to use the bridge. Then now we want to go and do the load cases. And the load cases, it's always good to, for now, there are standards. The codes as how you can do the load combination, how you can do the load cases. But you can also do, you can do direct from the software. You can go automatic from the software. So what we do is I will say my moving load 10. This one, my first case is my load model 1 plus the tandem system. It's even here, added here. And so there's no, here you see footway is 0 because it's not there. But here, this lane, I make sure I bring them here, and make sure you highlight where the remaining lane is. Make sure you take the remaining lane where is required here area, while the footway lane, if it was there, I would also bring it under this box. So now with that, I can now apply. So my moving load 10 is been applied. Then that is when you ignore the 5 factor. If I check in the 5 factor, I just change this to 1 and I apply. So it has given you, when you run, you will find that this with 5 factor I give more value than when it is without that. So it's good to run both. Then I go to load model 2. I'm going to add. It takes me here. Load model 2 has been, so I highlight this list of lane, take them here and add. Now it has brought me here for me to apply. So I put my load model 2 0. Then here, please also in the description put that load model 2 and remove this one first. So my first LM2, I add that one, then I put 2 1, and then I make sure the 5 factor is checked and I apply. Now I'm going to do my load model 3, which is this is the one which gives you the, make sure when you do it, it gives you the UK national annex. For us here in Uganda, we have not developed our national annex. We are in the process. The Ministry of Works is going to work on that. However, we normally adopt since we are under British protectorate kind of. We are colonized. Even our university study, we do a lot to do with British standard. Even the current BSEN. So we have also we normally use our national annex being the one of UK, but tailor it to fit like our temperature, our wind data. We don't take the one of UK and the rest, because if you look at temperature, Western world which experience snow loading, winter time, your temperature goes to negatives. We have never gone to that. We come down to about 15 and 17, then we go to about 35, even 35, 37. So those are the areas we modify. We don't verbatim copy what is on a national annex. Even temperature now, even wind. Your wind is extreme. Ours is not. Varies around between 5 meter per second to about 25. Then with some factors, then we play around there. So basically that, now we have that. So on load model 3, you change this to now, it is load model 1 plus LM3. So LM1 plus LM3 is my description here. And then here it is 30 in the first case with that, without considering the 5 factor. Then I apply. Then when I come here, I do my 31 and then leave that the way it is. I now checked in, I put that. Now this if you study this well, is the same nomenclature you would use if you are following the GI, the GRA, the GR1B according to court practices. So these are the load cases you have identified, and then now we could now say okay, fine with that one. Could now say that is done. I have defined. So what have I done here, gentlemen and ladies? I have defined the traffic lane in the surface, on the surface. I generated the vehicle to use the box culvert. I've gone ahead to define the load cases. Now, having done that, now normally something that I learned from other experts that taught me. So when you do this, now you come to analysis point, you go to moving load, and make sure you check that all these analysis results, plate, flame, calculation filters, they've been defined here. So you make sure all this, and then you click OK. So you can see that all these are activated, taking care of all that. So I've done all this. Now what I'm left with now is to run analysis, do the load combination, and design. But design requires us, the designer, to define these plates, define them so that you are able to design them when you go to design. The design is here. I've ever talked about. When you reach here, it's a different command you follow. So in the model here, make sure we first define what the bottom slab will be, how will be designed, the thickness, everything. Then when you run now, you want to do design when the software is aware of what's going to be designed. So it's what we call domain. So in the domain, we have this. You see this domain is defining different plates have been defined here. All these plates have been defined. This is what you need on a domain. But because this is by default, it has come automatically. I am going to delete this one, and I define it as a box. So this one I can delete it. So what I've done now is I'm left with, I'm going to define this as box culvert. And what will be our element list? I highlight all of them. All this box culvert is what I'm going to design. I highlight it, it has come there. So I add it there. That is the domain. Remember this, and you do it before you run analysis. This is very, very important. The light has gone now. You can't see me very well. Now you only see the teeth and you see this one here. This is serious. Okay. Having done my domain, that is the entire box. Now under the domain, now you go and talk about what are the components of the domain. That will be the bottom slab, it will be the top slab, will be the external wall, the interior wall, the wing walls, and the apron. So you have all those are subdomain. So I come to subdomain. You see now box culvert is already up. Now under subdomain, here, if I want to highlight the bottom slab horizontal, I come here under the member type, it is the plate. So plate beam will be the top and the bottom slab. Then the plate column will be the vertical member. So here I start with the plate, and here we do the local. That's how I was taught here, but people will explain more. So you make sure to put it at a local. Then under element list, I want to start with the top slab. I can now change this, and then I highlight my top slab. Now this top slab, I would actually highlight it as top slab. Actually the best would be, what we need to do is we need to highlight the bending area and the hogging moment. Very important. We need to be mindful of that. I could actually, for demonstration, only highlight the entire slab as one member, but it's also good to do what is realistic. So I would say I would do like hogging moment area, bending moment area as two separate. So I'm going to divide this into, like, the first part is these two from the external wall will be one member. That is top slab maybe one. Then then midway will be top slab 2, and top slab 3 will be the hogging. So I would now say my subdomain, I could say, let me pick this as my top slab 1. Then I add. I'm going to do my top slab 2 is from this. I can stop here, and also the same thing I can apply from 1, 2, 1, 2. Okay, I can also do, I think we were up to here. So that become top slab 2. I'm trying to make sure when you're designing, you should have a clue of which area am I designing. Mid slab is more of bending, while towards support is more of hugging. So that gives you a clue, but you can accurately calculate and get to know that. So I had that one. I've added now so then I have the hugging now. The hugging is here, and therefore I will call this as top slab. Maybe I can say it hugging, so that it is 3. I call it 3, so that if I don't forget. So that is what I will now add. Yeah, I'm done. Now, having done that, I'm now going to go and do the bottom slab. Bottom slab, I can just leave that. And so on the bottom slab, I can only pick this. So I can do the same thing. I can do this first part of the external wall. Remember, today we have a wall. This wall is here, the middle wall. So I want to take this near the external wall as my bottom slab 1. Then take the midway as bottom slab 2, and then the one which is hugging downward under the wall as bottom slab 3. So I now put this one as BOT slab 1. I add. Then I do, if this is this one, then I can take it up to here, and also I do this one up to here. Then I can do my bottom slab 2. I add. Then I do the hugging. The hugging will be around this one, and I do my bottom slab 3. 3 has the hugging. Please make sure they are in the order, because there's going to come time when you need to make sure they are aligned. Yeah, so basically that. So I've done, but remember we are left with under horizontal. We still have the apron. So for apron, I will not waste so much of our time. I'm just going to say apron left and apron right without doing anything. So I come in here, I call it apron left. I just add. These are on the horizontal plate beams, horizontal. Then I come to, that is then apron right. Apron right. So now I have defined horizontal members to be designed. The next I'm going to do is to define vertical members to be designed. So under vertical member to be designed, I want to make sure I just highlight this one upward, and then I pick that, I remove, I'm left with this, I'm left with this, and I'm left with that. So these are the vertical members that need to be designed. So I'm going to define, there's going to be external wall, and this under external wall, you can do up part, the middle, and the lower part, because you want to know the bending moment midway or towards down and then over the support. But for now, let me only do 1 because of time. So I'm going to do my external wall. Now here you change. This has to be plate column. And a plate column, I think. And a plate column, I think. This one is about, and the plate is here. So we go to subdomain. We go on a plate column. On a plate column, we do the local, and then I do external wall this and these two. I'm going to assume they will have the same thing, and then I'm going to put external wall. No, I think it's good to put them separate. So let me do external wall right, external wall left. I add. I do external wall right. I add. Then I do wing wall. I'm going to combine this wing wall, this one and the other one, these two wing wall as right. So they are vertical members. So I put ww right, wing wall right, I add. Then I go back here, I do my wing wall left. I do my wing wall wwl and I add. Gentlemen and ladies, I'm done with my domain and subdomain. I've defined them all. So all these members, I have defined them, and when I go to design, it will be there. So now, having done that, you save this, make sure you always save it. Then now I can run a design. So I come here, I do my design analysis, and then it's going to take some time because now you have put in what? Traffic. You can see that rolling loads take some time. But it's not too much, of course. It takes some time. The rest, static analysis and the rest, they're okay. Forming element stiffness move quickly, but when you come to moving loads, because there's iterative kind of traffic, so you're moving, going one lane, going backward, moving slowly, it takes some time. So that is how you're able to see. Now, when you look at this tree menu now here, you see even the domain one, under domain, you have all this subdomain. Falling under box culvert. So you have all this under box culvert, then you have your properties, then you have your boundary condition, then you have your loading, you have the traffic lane. Now all have been done. So you are done. So now that you have done, I can quickly go and make a result. I want to see how my traffic is also shaping my structure. I come back to my traffic, moving loads are all given here. Now this is the pressure due to traffic load. I can highlight it like this, and I'm able to view. This is traffic load. You will see how different they are. So you have this, then I have my traffic load 2. Then I have the third one. There were 3 types. So these are all different intensity. If I put for you the legend, you're going to see that they give you different values. See here, this one is actually 20, and that's the load model 3, while load model 2, it gives us bearing pressure of maximum only 8, you can see. Then load model 1, it gives us bearing pressure of also 8. Load model 1 and not 2, load model 1 is here. It's 20. So that's the difference. So having done this, we have seen the info. Now, what I want us to do now, for you to go to do design, you must do load combination. So with load combination, we are going to do automatic here. So we are going to go to results, load combination. Now this is being concrete. You come here with your concrete. Then you come to automatic generation. Then you have your load here, you have BS454, you have Eurocode. We are designing using Eurocode, and this is the Eurocode you have in here. Then on a load factor, we can use both serviceability and maximum or ultimate. Then I told you the snow load we don't have. Thermal act, we have not applied thermal temperature, but we can leave it. So you come on a road traffic, make sure for frequent values, this load model 2 is taken this side, and then you say yes, and you have your traffic here. You have the strength with all this factor given. Load model, every load case, it has a lateral pressure, vertical. You have what? You have the traffic. You have a traffic, you have a traffic, you have a traffic. So this one, I will not dwell too much because I see hydrostatic is missing. I would actually add hydrostatic in all my, but you can actually make sure they're all there. Hydrostatic should be there, but we shall have to find a way whereby automatically it can appear. But as a designer, you also make sure you don't forget anything. Make sure it is captured. Even we need to look at the load combination of hydrostatic. Is it for water would even be 1.5 because the way water affects our structure. But for now, for this demonstration, let me leave it at that. And then I do that. I'll put 1.35 for our demonstration. Lateral soil. that one missing out. Okay, 1.5. I will do my, but for you guys can now check the code. You throw in the comments, say this is what you found, because sometimes politics sometimes affect us. We are running up and down. You find you are not seeing some of the things. And okay, hydrostatic here. Okay, we leave now 1 for serviceability. That makes it easier. I can do hydrostatic 1 and then also hydrostatic here 1 and also hydrostatic here. Here you seem to be quasi. So let me not apply hydrostatic because this needs to be quasi. So we can you can look at spreadsheet forms are here. You can see all these things people normally see, even it's defined here. You can also say make for me this you can even print this one here. These are load combination. So having done this, gentlemen, we are done. You can now view the implication of the soil pressure again. If you want another load combination here, you have the different load combination 1, load combination 2. You can see that the intensity changes. But normally, you know very well for sizing you use serviceability limit state, and then for design you use ultimate in your foundation design. You are well versed with that. So having done this, gentlemen, now it is time to do design. So when it comes to design, I come now to design. I go to RC, I look at the design code recommended. I make sure I put all this. Consider axial load interaction plate column. I put all that. Axial load plus. You can now read and see what you want. So I say yes here. Maybe I can highlight all. Then I come to modify concrete. Is always very interesting. Make sure you come to rebar. We do the same RC, and the rebar type I think is class B, depending on the ductility level you want. And then make sure the grade is indicated. I say modify, and then having done that, and then I go to serviceability limit parameters. Here you see we have frequent value, we have quasi. These are the crack control is defined all here. And so even here, our exposure class, make sure we do exposure site condition. You need to know the acidity level of the soil, and then water quality, so that you are able to know the cover size type and the rest. They're all here, the XC1 up to that. So you apply this, and then now you look at the combination. If it's automatic, you find it already done for you. They're all here. The characteristic value has become here, the frequent value is here, and the quasi permanent are all given to you. If you read the code, you know all what these are all about. Having done that, gentlemen, you come now to, there's no section. So beam section, column section, we are not designing. It is the beam plate and the plate column. So under beam plate data, you come and look at the subdomain, and then make sure it is the average nodal. Now for here, now we can still leave direction. You can leave the stirrup we can define as we move, but the cover you can specify. And I told you need to know cover is depend on your site connection, but for now we can do 50 millimeters. I add, then I go to apron right, the same data remains, I leave. Then I go to bottom slab 1, I'm adding bottom slab 2, I'm adding bottom slab 3, I'm adding. Now I'm directing this thing to be recognized for. Then top slab 1, I'm adding, no, top slab 2, then top slab 1 and top slab 3. So this is on the bottom. We are dealing with only the plate beam, not the plate column. So having done all that, you close. You go to the next command is rebar for plate beam. Now you need to remember all what you've done. I think it was apron left. Apron left, now you see the layer, top reinforcement layer. What is the center? Let me say it is 0.15, and I'm using maybe 25 diameter, and the cover is 0.05. Then the bottom is also 0. Bottom stop, I also choose the same thing. For now, I just want to make sure we run a design and you understand. The rest now you do what they call optimization. Then you distribution bars. I think I'm going to do 0.16, no 0.15 per 16 millimeter diameter. So here is the 16, and then 0.15, and then 16. You still, and then the stirrup here, we are doing stirrups, you know, shear bars. I'm going to do 12. The spacing can be 0.4. When you read the code, you will know what we can do. You keep adjusting depending. So it is one close member. I add. Then since I've defined, then there's apron right. I add. Now assuming now I assume that this reinforcement will be used across, but I'm going to be adjusting element by element until you get an economic stuff to avoid conservative and a lot of waste of material. So then we have bottom slab. I said 1. Remember that I'm leaving all this reinforcement to be first uniform. We are not disturbing it. Then bottom 2, just have initial design. Bottom 2, you add, and bottom 3, we add. Then we go to top slab. Top slab 1. Top slab 1. We are adding, because we are assuming all the things are the same first, reinforcement and the spacing, and top slab 3. We are done. Then the third stage is very important. Make sure you match all of them. Now in the matching apron L here, average nodding, make sure it's apron L. So these two are there, you say add. Make sure when you go to apron R, make sure here also is apron R, you add. When you come to bottom slab 1, make sure it is also bottom slab 1, you add. If you swap it, it will not run. Bottom slab 2, you add. Bottom slab 3, you add. Top slab 1, top slab 1, you add. Top slab 2, you add. Then top slab 3, you see they're all supposed to be the same, and top slab 3, you add. Now this one is done. You can now run a design for this, but let's go and do for the vertical wall. You can save. Then you go back to design. Under plate, these three processes are very important. Make sure you do all of them. Then under plate column, we start with external wall right, and then average column, you put average nodules. We can leave this stirrup will come that side, but even the cover is the other side. So, but let me do that. Then this one now there's no matching. Matching comes towards the end. Then external wall left, I add. Then wing wall. I did not do interior wall, but we can leave it. You add. You can do it now as an exercise. This one you add. So having done this, I move and go to the middle one. Input in, and then this one is external wall R. This I'm going to do 0.15. I'm going to do this wall. Okay, let me just adopt that first. 0.05, and then 0.15. Then I put 25, but you can do then 0.05. You make distribution. I can do 0.15, and then I'm doing 16 again, and then also 0.15. I'm doing 16 again. Make sure the stirrup is defined. That is if stirrups, if you have any shear forces anywhere, 0.4. When you read about the thing, you will know. The code gives you a limit, I think 0.6. But anyway, let's try and see. I don't know how much we can do, but there's a lot of reading, gentlemen and ladies. So this is 2, and then you can now add. That means my L, I can also add, and then my wing wall L, I add. Assuming that the reinforcement are the same, but it's never the same. You have to spend some time in that's where now you have to spend time in understanding, not only. So I've now defined all that. Now I'm going to label to make sure the plate column are matching. External wall R, average noddling, external wall R, I add. External wall L, I add. WWL, I need to have WWL, I add. Then I have WWR, I need to have WWR, I add. I'm done. So having done all this, gentlemen, now I'm ready to run a design. So I want to design the bottom slab first. So I come into here, come into design check, not the beam, not the column, but the plate girder. So the design is going on. You see, it's saying prepare design information. It's going to run. But if you wanted it to move quick, you can actually highlight areas you think it can generate. It can work quickly. You don't need to highlight all this bottom and top slab. It's going to take a bit longer. So I would actually pick only the bottom slab or the top slab or upfront. Now what I did not do is to cut a section. Cutting section we can also demonstrate later, but for now, let me pray it give us the value earlier to avoid these further delays. I would have actually picked few plates to design. This one might delay us. This one might delay us. So basically, you realize that design, there's a lot more in making sure that you input all the right information accurately. The data that you collect from the field has to be well done. The people, the experts you use must collect the right information. The central point, like if you are the main designer, you make sure that the right information you need to input in your design is what you get. Where you cannot get the design information from the field, you can now do an assumption based on your subject matter expert idea. So basically that is what we normally have to do when we are doing this kind of design. It's very, very important and very important. The design sequence is very important, something that we normally forget. If you are real to have one or two information to do this design, who do you need here? I think geotech may not, for box culvert, geotech may not worry because you are going to enhance, in one way or the other, you are going to enhance your foundation using rock fill or rubber concrete. But hydrology is very important. The surveyor, very important. The highway guy who will give you the road extent, the pavement structure, they are very, very important. So I know there are quite a number of experts that we use, but sometimes you are at a fix. So just say, who do I need to quickly give me some information to start with? So very important. Detailing, you have to do detailing to reflect exactly what you have designed. Then the quantity takeoff comes from your detailing, where you have generated your quantity of concrete, the bar bending schedule for reinforcement in accordance with the standard of detailing. Then you do takeoff as an engineer, or you can support your quantity surveyors if you have. Now then you secure contractor and you implement. My only worry is implementation is a different dilemma. That is a dilemma to both the engineer, site supervisor, the engineer, the designer, and the engineer, the project manager. Sometimes we have a project manager who is not an engineer. That comes with its own what? Its own culture. Then quality control deliberation on site has its own dilemma. You specify concrete grade, the contractor begins to do design mix. And when they do design mix, you're going to get different quantities based on the specified mix or specified grade of concrete. So you begin fighting, quality becomes a problem, the density control. So many things do happen that need to be done. Project management needs to be at its best, and it must emulate, must really copy what the engineer dreamed about. If the project manager comes and says in project management, this one doesn't matter, we do this one, then you know project compliance will be tampered with. The project manager must verbatim relay what has been designed. If you bring a political talk in implementing what has been designed, then definitely you will not get the same thing. So these are some of the things that need to be looked at and then well thought through. Very, very important. I think what happened is we shall give it time. I think I wish I had started with the external wall. There were few than to go to the bottom slab and the top slab. They seem to have a lot. So it's actually now designing the bottom 1, bottom 2, then bottom 3, top 2, top 1, top 3, then apron L left and apron right. Now it has to do all that design. You have to go through the code requirement and everything. That's why it is taking a bit of time. Otherwise, if I had highlighted only 1 or 2 to be designed like apron, I put one plate. I put on 1 plate at the bottom slab, another 1. In total, could be 3 up, 3 down. That is already 6 plus 2, 8. If I had highlighted 8, would have moved faster. So let's see. I think it's also trying to do something. If we can have this generated, the rest can be, you can now run for the vertical wall. I will show you. You can run it and you get that. So this is in brief what it takes to design a box culvert, ladies and gentlemen. I have tried to run through so that you can follow at your free time, and I've used the nodal approach. I've also applied my traffic load. This is the output you get, ladies and gentlemen. So you can see it has passed. Now you have to go and have a look at all this. There are 3 output points. You can look at the graphics, and this is what you have, ladies and gentlemen. So you have your apron slab. The thickness is given. All these have passed. You can come to your apron. You go to bottom slab, and you go to top slab. They're all passed. Then you can save. Click a save as. Then you come here. It is already on a box culvert, and I call it. You can just call it box culvert. But the problem, it will be saving 1, so you need to save almost for all. So I just save 1. Then I can view the detail. This is the most interesting part that normally makes an engineer very happy. It gives you what we have been reading, what they have been taking us through in the college is what you will see. It will come with a kind of very good graphical stuff, reference point, and so that is what you can pick and attach to your thing. How do you report it? Reporting is another thing. Hey, it's a problem. I will get another session to do the report. For now, I've given you up to the last point. Your Word document is coming, and with this Word document, you can see domain. It will give you the bottom slab 1, design code, section property. They give you materials, the thickness, they give you the reinforcement, the summary as you are given. Now you can now play with the summary, and it gives you all the required moment, capacity, all that. You look at all this. Each element, each plate is designed with even crack width given to you. Quasi permanent, what I told you about that. Now this is bottom slab 3. So you are able to get, even you are able to understand. So I can now file of this, save it, and browse. I think also on a box culvert, 2 cells, I've saved that. So I'm done with that. You have seen the report. Because of the time, I may not be able to do so many things. So you are able, you have all this in place, and so now the last part will be how do you report. I will get another session, not today, to now get a report and share, but at least we have seen how you can go on and do that. Thank you so much.